Good day everyone, I am Marilyn Singhayao, and today I'll be presenting an analysis using PERT, or Program Evaluation and Review Technique, and CPM, the Critical Path Method. This is the two project management tools that help us map out activities, estimate durations, and identify the most important tasks in a project. Think of them as the quiet architects behind a real-time plan. So, in this presentation, we aim to construct a project network diagram, calculate the expected time using PERT formula, determine the critical path, total project duration, and activity flows. So, PERT and CPM are project management tools, and it helps estimate project duration, identify critical tasks that must not be delayed, and useful for small businesses with multiple steps before launch. For example, in this problem, you are planning a small milk tea business that involves the following activities, which is to create a business plan, to find shop location, to apply for permits, to buy equipment, to renovate the shop, to hire staff, to train the staff, to operate testing, and to the grand opening. In this table, we can see the list of tasks. They're optimistic, most likely, and pessimistic, and each of the activity has their own predecessors. Our task is to compute the expected time for each activity to analyze the whole project using PERT or CPM. So to compute the expected time, we will be using the formula TE is equal to A plus 4M plus B divided by 6. So let's compute first the activity A, which is A plus 4 times 5 plus 6 divided by 6 is equal to 5. And for B is 5 plus 4 times 7 plus 10 divided by 6 is equal to 7.167. This is rounded off into 3 decimal point. And for C is equal to 4 plus 4 times 6 plus 12 divided by 6 is equal to 6.667. And we will do the same process into D, E, F, G, and H, and I. Once we have all the expected times, we now identify the sequence of activities and draw the network diagram. So we will be using activity and predecessor because the predecessor is the activity direction. So in this diagram shows how tasks depend on one another and the proper flow of the project. So to compute network diagram, we can now determine the earliest starting time and earliest finishing time using forward pass method, which is earliest starting time is equal to highest earliest finish time, and the earliest finish time is the sum of earliest starting time plus expected time, and the latest starting time and the latest finishing time using backward pass, which is latest finishing time is equal to minimum latest start, and the latest start time is equal to latest finishing time minus expected time. So let's calculate now the project network diagram. So to solve this project network diagram, we will be following the formula that we discussed earlier. So here, since A don't have predecessor, so A starts the ES into 0. So 0 plus 5 is equal to 5. And then since A has 5 EF, so B has 5 ES, and ES plus T is equal to 5 plus 7.167 equal to 12.167. Then C since A has 5 EF, so CES is equal to 5. and 5 plus 6.667 is equal to 11.667. Then F, since C has 11.667 EF, so F has 11.667 ES, and 11.667 ES plus 4.167 expected time of F is equal to 15.834. And here D and E, since B has 12.167 EF, so the ES of D and E is equal to 12.167, and add to the expected time. So D has EF of 17.5 and E has 22.5. And G, since F has 15.834 EF, so the ES of G is 15.834. Then plus expected time 3.167, it will equal to 19.001. And then for H, since D has 17.5 EF and E has 22.5 ES and G has 19.001 EF, so since we were getting the highest, so we were getting the EF, so the ES of H is equal to 22.5. so 22.5 plus expected time of H is equal to 28.667. Then here's I, since 22.667 is the EF of H, so then I is from H, so the ES here is 28.667 plus 2 is 30.667. And now we will be going to compute the backward pass. So since this is 30 here and this is the finish, so our LF will be 30.667. Then we will subtract to the expected time, which is 2. So 30.667 minus 2 is equal to 28.667. And then backward pass, so since the pass here is 28.667, so here the LF here is the 28.667. So 28.667 minus the expected time of H is equal to 22.5. So here, since 22.5 is the latest start in H, and we will go to backward pass, so the latest finish of G, E, D is also 22.5, because this is the minimum and this is the only one that we backed from there. So 22.5 here, 22.5 here, 22.5 here. So 22 minus the expected time of G is equal to 19.333, and 22 minus 10.333 is 12.167, and 22.5 minus the expected time of D is 17.167. And then let's do the B backward path, since B is from D to E, so we will getting the minimum. So the minimum LS is the E, so we will use the LS of E to the LF of B, so 12.167. so minus the expected time of B is equal to 5. And then here, since, and then the F, since this is from G, then G has LS of 19.33, so the LF of E is 19.333 minus the expected time of F, so it will to 15.166. And then let's go to the C, since F has LS of 15.166, so LF of
of C is 15.166. Then minus the expected time of C equal to 8.499. Then the activity A, since we have B and C connected to the A, so we will be getting the minimum, since the minimum LS is B, so we will be using the LS of B to the LF of A, so 5, and minus to the expected time of A, so 0. Now we will be getting the slacks number of each activity to get the critical path. So to compute the slacks number, we will be subtracting ES and LS, or EF or LF. So 0 minus 0, or 5 minus 5. So the slacks number of A is equal to 0. And for B is 5 minus 5 is equal to 0. And for C, 5 minus 8.499 is equal to 3.499 negative. And for D, 12 minus 167 minus 17.167 is equal to 5. And E is 12.6 and 12.167 minus 12.167, so its slacks is equal to 0. And for F, slacks is equal to 11.67 minus 15.167 is equal to 3.499 negative. And for H, slack is 22.5 minus 22.5 is equal to 0. And then for G, slack is equal to 15.834 minus 19.133 is equal to 30 point... Second, by the way. 410. Is equal to 3.499 negative. And for I slack is equal to 28.667 minus 28.67. And for I slack is 28.67 minus 28.67 is equal to 0. So we can now identify the critical path, which is the slacks equal to 0. So that slacks that equal to 0 here is A, B, C, H, and I. So the critical path now is equal to A to B to E to H and to I. And our project duration is equal to the latest finish, and earliest is equal to earliest finish and latest finish, which is 30.667, or equivalent to 31 days. And that is how we get the critical end to compute the network project diagram.
And this is now the completed network diagram. It includes all the activities, expected time, and flow of the project, also the slacks and the total project duration. Now we can compute the project variance by summing all the variance of the critical paths, which is A, B, E, H, I. So to compute the variance of each activity, we will be using the variance formula, which is A minus B divided by 6 to the power of 2, which is A is the optimistic and B is the pessimistic. So let's compute the activity A, which is A minus 7 divided by 6 to the power of 2 is equal to 0.445. And activity B is 5 minus 10 divided by 6 to the power of 2 is equal to 0.694. And then the activity E, which is 7 minus 15 divided by 6 to the power of 2 is equal to 1.778. And the activity H, which is 4 minus 9 divided by 6 to the power of 2 is equal to 0.695. And then the activity I, which is 1 minus 3 divided by 6 to the power of 2 equal 0.028. So to get the project variance, we will be adding all of this variance of activity. So activity A, variance of activity A, activity B, activity E plus so the variance of activity A plus activity B plus activity E plus activity H and plus activity I is equal to 3.638. And then we were going to square this to get the standard deviation. So square root of 3.638 is equal to 1.907. Therefore, the PERT and CPM analysis shows an expected project duration of 30.667 days or equivalent to 31 days, with a total variance of 1.907 indicating low scheduling uncertainty. The critical path is A, B, D, F, G, and I, which define the minimum completion time. Any delay in these activities will delay the entire project. Overall, the analysis supports effectively planning, resource allocation, and timely project completion. That would be all. Thank you.